So here, as you can see now, this is just a quick warm-up of what we did last week. Last week we said as you can see, JKL is an inscribed angle because the vertex which is K is on the circle. Then the arc that is from across from it, which is called an intersected arc, definitely gonna be twice that quantity. So that's why arc is twice inscribed angle. So since the arc is, the inscribed angle is 88, if you multiply by 2, it's gonna give you the value of the JML, which is the intersected arc. So 88 times 2 gives us 176. So the other place here, we have the arc. We're looking for the inscribed angle. But what we know is that inscribed angle is half the arc. So if you take half of the arc that intersect that, that inscribed angle. So here you're gonna have 34. Since they said half, so you divide by 2, and then 34 divided by 2 gives us 17. So here this is 176, and this angle is 17. So another warm up here, we have this arc XW. We also have this arc XY, and we're looking for angle WXY. This WXY, this angle here. Whereas we don't know the arc that is formed across from here. But to get the arc, we know the total sum of angle around the circle is 360. So to get purple arc, the purple arc, you're gonna do 360 minus the red minus the green. The red is 86, the green is 156. So subtracting all these three guys, these two guys, gonna give us 118. So it means the purple angle is 118 degree. Then to get the inscribed angle, what do we do? Inscribed angle is always half the arc, okay? So we're gonna do 118 divided by 2, and that gives us 59. So it means this angle here is 59 degree. Okay, Tyra, welcome. Let me mark you present. Then the next problem by the side, here we are given the arc CS. We're also given this angle here, the inscribed angle RST. But we don't know the arc that is formed across, but we know that arc is always twice, as this implies, arc is always twice the angle, the inscribed angle. So here we're gonna do 42 times 2, which is 84. So that means this arc is 84. And then we are gonna look for the third arc here, which is RS. But we know that the green, the purple, and the red arcs add up to 360. So to get the green, you're gonna do 360 minus the remaining two guys, 84, and then 171. So that calculation gonna definitely give us 105. So which means this arc here is 105. So this is just a warm-up of what we did the whole of last week, lesson 1, 2, 3. Then today we're just gonna quickly go to a new business. Here, As you can see, we have a triangle on this circle. Sarah, the 3 points of the circle of the triangles, are they on the circle or outside the circle?
On the circle.
Okay, they're all on the circle. So, and those 3 points are called vertices, okay? And so it means an inscribed triangle is a triangle that all the vertices are on the circle, okay? So each vertex of the triangle is definitely an inscribed angle. Because as you can see here, if you take angle A, it's on the circle. If I take this angle here, this angle is on the circle. If I take this angle here, B, it's on the circle, it's inscribed. And if I take this angle here, this angle AD is also inscribed because A is on the circle, B is inscribed, and AD is also inscribed. Okay, so that's why each vertex of the triangle is an inscribed angle. That's what the statement means. And then let's find the values of these various arcs. Here, a green arc here, which represents A, has this intersecting arc, which is 140. And we know that arc is always, inscribed angle is always half the arc. So to get this angle A, you're gonna do 140 divided by 2. So that gives us 70. So that means this angle here is 70 degrees. Okay, and also to get the purple here, this arc, this purple arc, that will be twice the inscribed angle 80, and 80 times 2 is 160 degrees. So this arc here is 160 degrees. And for the red, we have this arc that is 60. So the inscribed angle here gonna definitely be 60. That will be half of that arc. So 60 divided by 2, which is 30. So that means this angle B is 30. So angle A gonna be 70 because it's gonna be half of the arc that intersect it. So this is 70. B gonna be half of the arc that intersect it, and the arc is 60, so half of 60 gonna be 30. Those are things we've done on Khan Academy last week. And then the arc formed at A, the arc formed here. Let me say the arc formed at C rather. Arc formed at C is definitely 160 degrees. So what do we observe here? We notice that around the circle, if you add, we just got here. Okay, are you back? Welcome, Tyler. So here, if you check very well, if you check the arcs around the circle, the sum of arcs, let's put the sum of arcs together. The purple is 160. The red is 60. And then the green is 140. So adding these three numbers, what do we have? 60 plus 140 is 200, 200 plus 130, 160 is 360. So that means around the circle, the arcs, the sum of arcs is always 360. That's why if one is missing out of the, the remaining arcs, always do 360 minus the remaining arcs that you have information about. And then in this triangle, what do we notice? Sum of angles in the triangle. In this triangle, the sum of inscribed angles, as you can see, angle A is 70. Angle B is 30. And then the purple angle is 80. And then when you add all the three numbers, 70 plus 10 is 70 plus 30 is 100, 100 plus 80 is 180. So which means the sum of all arcs in the circle on the circle is 360. The sum of measure of all arcs on the circle is 360. And then the sum of angles in a triangle is 180. Inscribed, whether this triangle is inscribed or is standing alone, the sum of angles is always 180. Never forget these two numbers. In a triangle, sum of angles 180, and sum of the measure of arc is always 360. Then we're gonna go to the next page to solve some problems. Here, who can describe this triangle in a circle? What kind of triangle is that? What does AC represent in this circle? From A to C, this distance here. What does it represent? Savannah? What does AC represent in a circle? Okay, thank you, Savannah. She said the diameter. So here, as you can see the diameter, then the angle that is formed here, if you have an inscribed triangle and the diameter is part of the triangle, that means that triangle gonna be a right triangle, okay? Always keep it at the back of your mind that whenever you have an inscribed triangle such that one side is the diameter, then that triangle is definitely a right triangle, okay? So here, which means this angle here gonna definitely be right. And since this is the diameter becomes what? The hypotenuse. So if this angle is right, this angle is 90, that means the arc that is formed across gonna be 2 times 90, which is 180. So as from today, an inscribed right triangle is a triangle in which the diameter is always the hypotenuse, okay? So here a right triangle is inscribed in a circle if and only if the hypotenuse is the diameter. And also we have, since we're talking about polygons start with triangle and then it goes on with quadrilateral, pentagon, and all the goons you have in this world. So if we are dealing with four-sided figure, an inscribed quadrilateral would definitely be a quadrilateral is inscribed in a circle if and only if its opposite angles are always supplementary. So as you can see, last time we had a problem where, last note where, I was trying to find, we had a four-sided figure on a circle and then we're finding X and Y in our homework. So this is the kind of problem we need, the idea we needed. So if you have a four-sided figure in a circle, then opposite angles are always supplementary. If it's a parallelogram, opposite angles are congruent, okay? But in the case of a quadrilateral, because in a quadrilateral, it's not necessary that opposite side will be parallel. Then if the opposite sides are not parallel, then we have just an ordinary quadrilateral. In that case, opposite angles are always supplementary, which means they add up to 180. So if they are supplementary, that means the angle at D and the angle at F. That will be measure of D plus measure of F will always be 180 put together. The other place, E and G face each other. So which means the measure of angle E plus the measure of angle G will add up to 180 as well. F and D face each other, then that's why they add up to 180. Okay, and you know in a quadrilateral, the sum of angle is 360. So if you have 180 to 180, you have 360. Definitely, it works. So here we have two problems and we stop here today. Here, what do we notice? We see that one side of the circle is the diameter, as you can see, AB. That means the inscribed angle here gonna be a right angle. So this is an inscribed right triangle, okay? And if this is a right angle, that means 2x gonna be what? Equals to what? The angle at C, what does it represent? If it's a right angle, what's the number that represents right angle, class? What is the measure of right angle? You said 90. So it means this angle here originally is 90, and is also, you know, it's also represented by 2x. So if you have 2x equals to 90, what should be 90? Okay, we divide both sides by 2, then x becomes 45. And then the other side, we have a four-sided figure, which is a quadrilateral that is inscribed in a circle. Then in our last statement here, we said opposite angles are supplementary. So we're gonna face, y gonna face 120, which means y plus 120 gonna be 180. Then y becomes what? 180 minus 120, which is what? 60. So which means y is 60. The other way around, for the other one, D and F face each other, which means they add up to 180 as well. D is Z, and then F is 80, add up to 180. If Z plus 80 add up to 180, that means Z gonna be what? 180 minus 80, which is 100. So today's note is quite short because the only information we wanted to bring is that if we have a triangle in a circle that is inscribed, you know, all the vertices are on the circle. And also, if the diameter is one side of that triangle, that means we have an inscribed right triangle, okay? And the diameter will always be the hypotenuse of such a right triangle. Okay, so, and then some exercises that you might be asked to find maybe one of the sides or the angles, you know. So you just base your knowledge on your, you know, your prior knowledge, you know, your prior knowledge of inscribed angle that is always half of the intersecting arc, okay, or the central angle that is always same as intersecting arc, okay. And if you also have a more than three-sided figure like a quadrilateral, opposite angles are always, you know, they add up to always 180, so they're always supplementary. If you have a quadrilateral that is inscribed, the opposite angles are supplementary. And if it's in case of a triangle and the diameter becomes, if the diameter is part of that triangle, that means we have an inscribed right triangle and the diameter is always the hypotenuse, okay, of a right triangle. So that's the information for today. So I'm gonna stop the record and I'm gonna stop recording and then we're just gonna go to the home.